Hello everyone, welcome back to another video for the series. I'm Yu, and today I brought an algebra problem that is related to polynomials. The reason why I brought this problem is because each step in this solution uses very rudimentary ideas, but the entire process, like the structure of the solution, is what was interesting and intriguing for me. So that's why I brought this problem. Yes, so without further ado, let's start. Solving integers the equation, this. So if you just take a look at it, it might look like a number theory problem, but it's actually something related to quadratics. And it looks quite messy right now, so we need to calm this equation down. So I think the way to do that is let a equals x plus y and b equals xy. That way, rewriting, we can rewrite it as a squared minus b equals a over 3 plus 1 cubed. And notice that 3 divides a because a squared minus b is an integer, because x and y are integers. Therefore, let a equals k. I think k is a good variable, 3k. Okay, then substituting, we have 9k squared minus b equals k plus 1 cubed, which is equal to 1 cubed, which is equal to k cubed plus 3k squared plus 3k plus 1. Therefore, why can't I write today? B equals negative k cubed plus 6k squared minus 3k minus 1. Then so we know that we defined a as x plus y and b as xy. Then I think it's quite obvious to write a new equation based on a and b because we cannot really continue from here. So for an equation in T, let's consider this equation. Then T should be x and y by VHS formula. That means its discriminant is a square number because x and y are integers. Let's say m squared. What is its discriminant? For m should be an integer too. Oh wait, does it have to be an integer? Wait, yeah, it should be an integer because a is also an integer. Yeah. Okay, then we know that a squared minus 4b equals m squared. And what is a? 9k squared plus 4k cubed minus 24k squared plus 12k plus 4 equals m squared. So rewriting it, we have minus 15, is it? Yeah, 15k squared plus 12k. What? 12k plus 4 equals m squared. And let's vectorize this. By rational root theorem, our roots should be plus or minus 1 over 2, 1, 2, and 4. Oh wait, 1 over 4 also works, but let's try from 1 because I don't want to try fractions yet. 1 doesn't work. How about 2? 32, 24, 56, 60, 60. So 2 does work. So factorizing, we have 4k squared, that is negative 8, so negative 7k. 14, so minus 2 equals m squared. Let's factorize this one more time if we can. 1 doesn't work. How about 2? 2 for 16, it does work, so we can factorize it as 4k plus 1, yeah, equals m squared. Therefore, 4k plus 1 equals a square number. So this is this is a square number, but notice that 4k plus 1 itself is an odd number. That means it should be a square of an odd number, because even times even cannot be odd. So this was one thing that was quite important, because to be honest, I actually had to remake this video because I just made it like equal to like n squared, and it was quite messy. So this clears things up. So let's find x and y now. So we know that t is equal to, which means x and y are equal to a plus or minus square root of the discriminant, and that is k minus 2 times 2n plus 1 over 2, and this is obviously, what is a? A is 3k. 4n squared plus 4n plus 1. Therefore, k should be n squared plus n, right? K is n squared plus n. So write it like this: 2n plus 1 . So this is equal to 3n squared plus 3n plus 2n cubed plus 4n squared minus 3n minus 2, or plus 3n minus 2n cubed minus 4n squared plus 3n plus 2 all over 2. So this is n cubed. Wait, 7? 7? No way. No. 7? How do we get 7 here? 7? 2. Oh, it's 3. Plus 3n squared, cancels out, and minus 1. Or negative n cubed plus 3n plus 1. So and obviously n is an integer here. Therefore, the pair x comma y is equal to So this could be x, this could be y. But we could also switch them because the equation here is symmetric. So this is equal to or yes. So yes. For an integer n. So this is our answer, but I'm going to now show why this is the only answer. So throughout the video, you might be like, how do we know that this is the only answer, the only solution? Because we just kept moving on to next step, but we didn't really prove that that is the only solution. So let's just think about this logically, and this was the beauty of this problem. Like in the beginning of the problem, this video, I mentioned that I really love the structure of the solution, and here is the structure that I'm going to first share. So let's take a look at it. A and B. So we wrote our equation with A and B, and actually B and K. So these are the same equation and nothing changed. So this and this are if and only if condition. So this equation is identical to this equation. We didn't change anything. They're just the same thing. So we had our first step with rewriting the equation. So that means if we solve for K and B here, that will automatically solve for this equation. And we actually did the same thing. So we just wrote that mathematically. So that is right here. So I said that when we find B and K, we will be able to find X and Y. So that's why they're the same equation. And no, that's not the reason why they're the same equation, but yes, anyways. But writing that more mathematically, we have t squared minus at plus b equals 0. That's more mathematical description of what I just verbally said. Now here is a slight error, also a controversial part. We use discriminant, but actually this was an important factor, so we derived an important information from the second equation right here. So let's talk about this information right now. So if this is not true, then we don't have a solution. So meaning this must always be true. So even though our scope of the solution got smaller because of the discriminant, we know that that would actually lead to x and y. So anything that does not comply to this thing right here, this discriminant right here, they're not the solutions. So we just derive I would say narrow it down from step 2 here. And I think from here it's quite obvious because it's quite simple, because knowing our limitations with discriminant, we just found x and y, and that just led to the answer. So we just used our first condition here again and merged it with step 3 to get the answer. So I think this is the general structure of the problem. So number 1, number 2, they're saying they just repeated the problem to make it more clear. Then we derived an important factor from step 2, and then using that step 1 and step 3, we didn't miss any solution because number one is just the same thing as the problem. Number three is the required vector in order for x and y to be an integer solution. So we didn't miss a single condition right now. So merging those two, we get a solution. When I first read the proof for this problem, and when I first tried this problem myself, I realized that I was quite lost while solving the problem, because I was like, I think I missed a condition, and I was not able to fully solve the problem because I didn't keep track of my ideas. But I think this structure of the problem was what led to I would say complicated mind when solving problems, and this structure of the problem taught me lots of things. And yes, so overall I really enjoyed this problem, and I hope you also enjoyed it. So I don't know why, but today I can't really speak well, I can't write well today. I'll try better in my next video. So thank you so much for watching this video, and I will see you tomorrow. Thank you and bye.